All right, guys, we're going to keep on writing these equations and practicing. This is the back of the handout that you did previously, last night probably. What I'm going to do is take me a sheet of notebook paper, and I'm going to split it right down the middle. I'm going to just make me a little column over here. Ooh. I'm gonna make me a little column right there that says equation. And then work. Okay? So that I can write the equation and then come over beside it and show my work for each problem. So let's number these on our paper just so we can keep them straight. We're gonna number across 1, 2, 3, 4, 5. Sorry, 1, 2, 3. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay? So then I'm just gonna come back with my notebook paper. And you can do this in your OMG if you want to and just have extra practice in there, extra notes. But I'm just going to look at number 1. Now keep in mind, we are looking for a variable term, an operation, a constant term, and then a total. All of them won't exactly fit that mold, but most of them will, and that is just a good way to kind of break things apart. A plumber charges $55 for a service call plus $35 per hour. All right, so first of all, $55 is a set fee. Let's come right over here and make a few more notes, just to our notes to self. 1, set amounts, things like fees, etc., will be a constant term. Write a per statement, and that will help you know where your variable term is if you can. Sometimes you can't, but if we can find a per statement, that's going to help us, okay? So $35 per hour. So there's my per statement. So there's my variable term. And we want to know if the plumber's bill was $160. So that's my total. Okay, so here we go. Variable term, an operation, constant term, equals, and total. All right. My variable term, $35 per hour. So I'm going to call that 35H plus my set fee of $55 is going to be $160. And then my work over here will be 35H plus 55 equals 160. I'm going to go through and write all of the equations with you. Now, if you want to come back over here and let's write the equation over here. Let's do that. You don't have to solve it over here. We can just do it here and then come over here and write it. I'm going to solve these on here and post the key in Google Classroom later. I'm going to write the equations with you. I'm going to let you solve them. And then you can go back and check your work on solving them from my key. But I'm going to write them with you on here so that we can make sure that you get some additional instruction on the writing piece. The writing piece is the biggest piece now. I think the solving you kind of got are getting better. The length of a rectangle is twice the width if the perimeter of the rectangle is 60. Oh, Lord, here's another one like that one we had on the front a few minutes ago. So, before I do anything, I'm going to draw my rectangle because I like, with these problems, I like to see my rectangle. I like to be able to see what I'm doing. The length is twice the width. The length is twice the width. Okay? So the way you can look at these is, if the length is twice the width, then the width is going to be your variable. The length is twice the width is going to be your variable, because I'm going to have a width and a width, but then my length is going to be twice the width. So it's going to be twice the W, twice the W. We can't have two variables in our equation and be able to do anything with it. We got to have one variable. So we've got to have both of those, the length and the width, represented with one variable. All right. So we've got our width, and then our length is twice the width. So we have our width, and then our length is going to be twice the width. But now look at what we've got. The perimeter, remember yesterday, the perimeter is all the way around. So what does that mean? It means I got to pick up every one of those terms. So I've got a W plus another W plus a 2W plus a 2W. And I wrote those plus signs kind of big just because I wanted you to see that this is one side, this is one side, this is one side, this is one side. And all of that is equal to 60. So there is your equation. So our equation for this one is W plus 2W plus 2W equals 60. Now, I am going to work this whole problem with you. And the reason I'm going to work this whole one is because of the question. Find the area. Okay? Find the area. So we got to find the length and the width first. This problem is very multi-layered, okay? So I'm going to work all the way through this one. Some of them I may not work the whole thing, but some of them that I feel like. So first, before we do anything, let's just find the length and the width. So first, let's solve for W. So right here, we're going to combine like terms. We're going to combine like terms right here. So we got a W and so we got a W, that's a 1W, a 2W, and a 2W. 2, 4, 5, 6. So that's 6W. So what do I have 6W equals 60. So now I divide both sides by 6, and W equals 10. So my width equals 10. My length equals 2 times, and I'm going to go back, it's 2W. W is 10, so it's going to be 2 times 10, which is 20, okay? So my length and my width are 10 and 20. So I'm going to come right here and label this 10 and 20, okay? The area equals length times width. So now that I know my length and my length is 10, my width is 20, that means that my area is going to equal 200 units squared, okay? And I'll go back and fill that in. But you had to find the length and the width, then go back and find the area. So that one was a little multi-layered. That's a good question. You really need to work on making sure you understand that. And that means going back and watching this and rewatching it, watching it, rewatching it, working it, reworking it, working it, reworking it, till you just got it. The Nile River is 690 kilometers long. This is let's back up. The Nile River is 6,690 kilometers long. This is 1,160 kilometers longer than the Yang whatever river. How long is that river? Okay. So we have the Nile River. All right. So let's just think about this for a minute. This is going to be one where we're going to have these two things are going to be kind of equal to each other. So I'm going to come over here to my brainstorming page first. I have the Nile, which was 6,690. And then I have the Yanks. I don't know. And it said that it was this 1,160 kilometers longer. So this one was 1,160 kilometers longer than the Nile. All right, so, and it wants to know how long this river is. All right, so again, this is one of those, you know, we're going to go back. We're just going to work it the way we know to work it. So we know that we're going to be adding. So if we add those, let me make sure I did that right because my brain was jumping all over the place. One 6,690 plus 1,178. What's 7? Yep, I didn't have to carry anything right there, did I? All right, 7. All right, so we had to add. So we got to write our equation. We're going to need to subtract this from this. So this is going to be our total. That's going to be our total. And what we know is that the Yang, whatever river, or plus, or X, whatever amount we want to put there, plus 1,160. Yes, because oh wait, no. I'm sorry. We did this wrong. I read that wrong. Let me go back. This means this is this much longer. So this is this much longer than the Yang. So the Yang's River is shorter. So what we have here is the Yang's River is shorter minus, all right, so we know it's shorter. So we know we would subtract those. And we would get that. So that's going to be the answer. That's going to be our answer. But we got to get to the equation. So to get to the equation, we're going to have to do the inverse. So this is going to be we're going to take the length of the Nile River and we're going to subtract this amount from it. And we're going to add this amount to it. I mean, the length of the Yangtze River. Sorry. I'm sorry, y'all. We're going to call it X. We're going to take X River, add this amount to it to get 6,690. When we do that in our equation and work it, when we subtract in our equation, X equals, there's the subtraction that we just did, like we did right there. So basically what I'm saying to you is, if you have trouble setting up your equation, work the problem, figure out how to work it, and then do your inverse operations to help you write your equations. So the equation for this is the X river plus 1,160 is going to equal the length of the Nile River. And I kind of worked all the way through that one too. I'm sorry I was all over the place on that one. My brain was just jumping around. A waiter earns $128 for 6 hours of work. The total included $86 in tips. How much does the waiter earn each hour? Okay. So, 120, all right, let's just think about how we would work this first. 128 hours for 6 hours of work, and that included $86 in tips. Well, let's get the tips out of there first. So 128 minus my $86 tip. It's going to be $42. So he earned $42 in 6 hours. So if he earned $42 in 6 hours, and we want to know how much he earned in 1 hour. Well, to me, this is a proportion, and I'm going to set up the proportion and figure out the unit rate, and then I can go back and look at how to write my equation. So he earned $42 in 6 hours. This is my dollars, this is my hours. And I want to know how much he earns in 1 hour. So I'm going to cross multiply and get 6x equals 42. And there it is. So there's my, wait a minute, divide both sides by 6 and x equals 7. So he's earning $7 an hour. That's going to be our answer. So now let's look at how we want to write our equation. It's going to be, all right, so $128 for 6 hours of work. We've worked through our proportion. All right, I showed you. We worked through our proportion. Now, we're going to use this piece of our proportion. Well, not that, but this. What I needed to know was this right here. I needed my variable term, and that just kind of helped me get to that variable term. Here's my total. My 128 is my total, and my 86 is my constant term, okay? So I've got my variable term, my my operation, my constant term, and my total. So my variable term is going to be 6x. 6x plus the $86 in tips is going to equal $128. And if you see, that's what I've got right there. So this, putting it up in the proportion, what the proportion did was helped me make sure I got my variable term set up correctly. Because sometimes, I'm not going to lie to you, sometimes I get a little bit, my head just doesn't get completely around whether I'm multiplying or dividing. So it just helps me. But here's that first step, that constant term step. So we knew we had to subtract out those tips, and so that was that first step. And so when we solve this, you see, we're subtracting 86 from both sides. There's us pulling out our tip, and we get 6x equals 42. Now, we're going to divide both sides by 6, and x is equal to 7, which is what we got right there in our proportion. So we know that we're right there. And you can see from this that there's more than one way to solve a problem. Solving a problem and getting to the answer is not the big deal. The big deal is making sure you can recognize the equation. And sometimes you have to get to the answer and then work backwards to get to the equation. And working backwards is a problem-solving strategy that's very effective. 3 sisters each purchased 2 dresses and a purse. The purse cost $26. If the grand total was $205.50, how much did each dress cost? So we each purchased 2 dresses. All right, so sometimes I just like to do this. We each purchased 2 dresses I got a dress, and a purse. The purse costs $26, so there's my total on that. I've got 2 dresses, which is going to be 2D, plus 26. Now, this is what each sister bought. This is each sister. And we have 3 sisters. So this problem is a distributive property, because what we're going to have here is 3 sisters. Each bought 2 dresses plus a $26 purse, and they spent a total of $205.50. So what we have here is 3 times the quantity of 2D plus 26 equals $205.50. I got to make that a little bit smaller. 3 times 2D plus 26 equals $205.50. Okay? Like I said, you're going to solve these, and then I'll go back and work them and put the answer key in for you to see the answers. Emma's sister is 9 years older than Emma. Their combined ages add up to 49. How old is Emma? Here's the trick to these problems is deciding who's the youngest. When you have consecutive integers, you want to get the youngest or the smallest. The smallest is going to be your variable. So Emma's sister is 9 years older than Emma. Emma's the youngest. So Emma is the youngest. Emma is the youngest. The key is to find the youngest. That person's going to be your variable. So we're going to call that E. Emma is the youngest. The sister, the problem says, is 9 years older. So the sister is Emma's age plus 9 years. And then their total is 49. Okay? So, what do we have? We got to take Emma's age plus her sister's age, which is E plus 49. I'll put a big plus sign right there. That's Emma's age plus her sister's age. E plus 9, sorry. E plus 9. And that's going to give you a total of 49. So you're going to combine like terms and then solve. So I'm going to write that right here. And then you will work that one. 1 year, Michael read 18 books. This was 4 fewer than twice the number of books that Jeff read. How many books did Jeff read? Okay, so Michael read 18 books. That 18 is 4 fewer than twice the number of books Jeff read. So, twice the number of books Jeff read minus 4 is going to equal 18. Twice the number of books Jeff read minus 4 equals Michael's books. Because it said this amount is this right here. So what that says is they are equal to each other. That this is Jeff's books. This is Michael's books. That's Michael's books. And so Jeff's books equals Michael's equals 18. So you're gonna be setting those equal to each other. 12J minus 4 is Jeff, and that amount is 18. Samuel is saving to buy a watch that costs $169. This is 48 more than 4 times what he saved last month. How much did he save last month? So we know that the 169 is going to be our total. That's number 7. Number 8. So we know that the 169 is going to be our total. That amount is 48 more than 4 times what he saved last month. So 4 times what he saved last month plus 48 is going to equal 169. And when you get to the end, you will have the M, which is last month. 4M plus 48 equals 169. Mr. Martinez rents a car for 1 day. The charge is $36 plus 18 cents per mile. Whew, here's a good one. 18 cents per mile. We got our per. So we know that's going to be our variable. So we're going to call that 0.18 M. Mr. Martinez has a budget of $60. How many miles can he drive? So our variable term is going to be 0.18 M plus our constant term of $36, and that's going to equal our total of 60. All right, so you work those, get those worked out, and I will put the key for you to check your work in Google Classroom. But that's writing those equations, which is the biggest part of what we need to do. Okay? And I want to go ahead and look at writing and solving equations, the little mastery check practice, because we are going to use, this will be your mastery check. It's coming up. So let's go ahead. Okay, so let's write these. This is going to be your practice for your mastery check. Andrea earns a flat fee of $20 per day plus an additional X dollars for each. Andrea made $10 in sale last Saturday. Oh, this sentence right here is what I love. The equation. It gave me the equation. I don't have to do anything but come right here and rewrite this equation. Plus 20 equals 80. Now I'm going to solve it. $20, I got to subtract 20 from both sides. 10x equals 60. Divide both sides by 10, and x equals 6. So my answer there is A. When Carrie mows the lawn, she charges a flat fee of $5 plus an hourly rate. The equation, look at there, gave us the equation. Ha! Love it when it gives us the equation. R plus 5 equals 20. Subtract 5 from both sides. 2R equals 15. Divide both sides by 2, and R equals $7.50. B. When Josh babysits, he charges a flat fee of $4 plus an hourly rate of Josh worked 4 hours at his last job. The equation below. Oh, yes, gave me the equation. 4R plus 4 equals 22. Subtract 4 from both sides. 4R equals 22 minus 4. My brain is hurting. Divide both sides by 4. R equals $4.50. B. What is the value of X? Well, let's just solve this and see. Gosh, this seems so easy now based on what we've been doing, doesn't it? Subtract 35 from both sides because my equation is on the on the right. 5x is equal to, this is a negative 10. Divide both sides by 5. And x is equal to a negative 2. Mr. Wilson wants to park his car in a parking garage. To find the cost, he uses the equation. Where D represents. So let's just do it. If Mr. Wilson spent $30. So here's where D represents the total amount, and he's going to spend $30. So here, they gave us the equation D equals 3H plus 6. But we've got to know to take that 30 and go put it right there. We can't solve this equation until we have a total. So $30 goes there, 3H plus 6. Now I'm going to subtract 6 from both sides. And 3 h is going to equal 24. Divide both sides by 3, and 8 is equal to h. Are all of these B? Just about. The formula for the perimeter is this. The perimeter of the rectangle below is 20 yards. So, what we have here, what is the width? We want to know the width. This is the length. So, let's write this down right here first and talk about how we're going to substitute into this, okay? We want to know what is the width. So this is what we don't know. The perimeter is 20. It told us that. So that's P. P is 20. The length is 2. So we have 2 times 2 plus 2W. So we have 20 equals 4 plus 2W. Subtract 4 from both sides. 16 equals 2W. Divide both sides by 2. And W equals 8. Look at there. They're all B except for one. Let's go back and look at these last two. These last two, even though the equation was kind of given to you, you still had to take the information in those problems and know where to put it and substitute it. Because it gave you this equation, but you had to know that this perimeter right here went in for P. You were looking for the W. We were looking for the width. The length is given to you right there in the picture. So make sure you're reading the diagrams real good because L is right there. So we substituted this 2. I'll just do a little bit of color right here just to help you. This 2 went right here. Okay? That 2 went right there. This 20 went right here. And that's what gave us what we needed to be able to then, you know, we can't have too many variables. We can only have one variable that we're solving for. So we either got to have values, we've got to do something to get it so that we can solve it. But these are your notes, and this is kind of the practice for the mastery check that you'll be having Thursday. So get this done, go back over it, review it, watch it, watch it, watch it. Don't forget to go back over this again if you need to. You got all of the ones from this week, and let me know if you have any questions.